Dear students, in this video we are going to learn about the concept of clustering in machine learning. Clustering is an unsupervised algorithm. It discovers groups of similar things, ideas, or people. Unlike supervised algorithms, we are not training clustering algorithms with examples of known labels. Instead, clustering tries to find structures within a training set where no point of data is the label. So that means in clustering, we are going to use unlabeled data and we are going to find out groups of similar structures in the training set. And the points in the training set do not have any data labels. There are various types of clustering algorithms are available. Partitioning clustering, hierarchical clustering, fuzzy clustering, density-based clustering, model-based clustering. In this video, we are going to learn about the concept of the partitioning clustering methods. The partitioning clustering method uses mean or medoid to represent cluster center. It adopts distance-based approach to refine the clusters. It finds mutually exclusive clusters which will be in the shape of spherical or nearly spherical shape. It is most effective for the data sets of small to medium size. So in this partitioning clustering, it uses the concept of mean or medoid in order to find the centers of the cluster. It adopts distance-based approach to refine the clusters. And the clusters are generally in the form of spherical or nearly spherical shape, and the base clustering is suitable for small to medium sized data sets. Two of the most important algorithms are used by this partitioning methods. One is K-means clustering algorithm, another one is K-Medoid clustering algorithm. In K-means clustering algorithm, the centroid of the prototype is normally the mean of the group of points. That means given the group of points in the data set, the centroid is the mean of the group of the data points. In most of the cases, the centroid does not corresponding to any actual point. For example, if we take mean of the data points like 1, 2, 4. So the mean of the data points is 7 by 3. 7 by 3 means it approximately through 2.33. It approximately 2.33 something. So there is no point corresponding to 2.3 in the given data set 1, 2, 4. So that is the meaning the centroid does not corresponding to an actual point. Medoid clustering, it identifies one of the point as the representative point to group the points in the data set. So that means 1, 2, 4 is the data set given. So it identifies either 1 or 2 or 4 as the representative point and is considered as a centroid in the cluster. So medoid is corresponding to the actual point in the data set. That is the difference between K-means clustering, K-Medoid clustering. K-means clustering, the principle: assign each of the n data points to one of the clusters of K, where K is the user-defined parameter. So that means if there are K clusters are there, the n data points are there, each point will be assigned to one of the cluster in K-means clustering. So the objective of the K-means clustering is to maximize the homogeneity within the clusters and also maximize the differences between the clusters. That means all the points within the same cluster should be of homogeneous type. And if you consider any two clusters, they should have the differences. That means they should be heterogeneous. So points within the same cluster are so homogeneous and they are heterogeneous with respect to other clusters. So that is the difference between homogeneity and heterogeneity. The homogeneity is measured in terms of the distance between the objects or points in the data set. Generally, the homogeneity of the cluster is identified by finding the distance between the objects or points in the data set. Now let us take up the algorithm steps for K-means clustering algorithm. In the step 1, we need to find out K points in the data space and mark them as initial centroids of the clusters. So first we need to find out what is the value of the K. It may be either 2 or 3 or something like that based on the given data set. We need to have some knowledge about the data set so that the choice of the value of K will be easy. So first K value will be chosen either 2 or 3, something like that. We need to fix some value of K, that is user choice, and assign each point in the data set to the nearest centroid. So we need to assign the randomly chosen centroids will be there based on the number of values of K. The K number of centroids will be there. Each point will be assigned to one of the centroid based on the distance calculated using the Euclidean distance formula. Then after assigning the points to one of the centroids, then we need to calculate sum of the squared error to measure the quality of the clusters. So after calculating this sum of the squared errors, we need to identify the new centroid of each cluster based on the distance between the points. This process is repeated until the centroids do not change. So the main fundamental property of the K-means clustering is the number of clusters is defined in advance. Now let us see one example how this K-means clustering works. Our goal is to find a few similar groups in a data set, like these are the points in the data set. We need to find out the groups of similar data points. Initially, we randomly place some K number of centroids. Here K is chosen as 4. So 4 randomly chosen centroids are placed in the data set. That is the first point. After that, we need to assign the points which are nearer to the randomly chosen centroids. So like this, these points, these 2 points are nearer to this centroid. These points are nearer to this centroid. Like that, points which are nearer to the centroid is identified and they are grouped. After finding the grouping, again we need to calculate the mean of the newly formed cluster. So therefore, this is the previously identified centroid. After grouping the points to this particular centroid, we need to calculate a new centroid. So the new centroid is identified by using the mean of the points within that cluster. Similarly, this is the previously identified centroid. Now the new centroid is identified based on the points grouped in this cluster. Likewise, new centroid for this group is identified here. It is visualized like this. A is the old centroid. Based on the points assigned to this A new centroid is computed. B is the old centroid, new B is computed. C is the old centroid in this group and the new C is computed. After computing these new centroids, again we want to calculate the distance between the each and every point in the data set with respect to the newly computed centroids, and we need to group all the points which are nearer to the centroids. So likewise, this step is repeated until there are no changes in the centroid points from the previous step to the next step. Likewise, number of iterations are finding the value of K. There is no easy answer to choose the value of K. The value of K is computed by using two methods. One is K is equal to root of n by 2. Another one is elbow method. Suppose if n is equal to 8, the root of 8 by 2 is equal to the root of 8 by 2 is equal to root of 4, that is equal to 2. That means the value of k is 2 here in this example. The value of k is 2. In this way the value of k is calculated. And another method is called elbow method. In elbow method, first we need to compute sum of the squared error for some value of k. That means we initially start with k is equal to 2. We need to calculate the sum of the squared error for 2 centroids for all the data points. And this process is repeated for k is equal to 3 and k is equal to 4. So we need to plot a graph with respect to the k value. What is the sum of the squared error? Like this, a graph is to be plotted, and we will find a drop in the graph where the value of k is optimal. In this way, the value of k is identified from the elbow method. This is optimal value. How do we recompute the cluster centroids? To recalculate the centroids of the data set after each iteration, the equation to be followed is the Euclidean distance between 2 points is computed by using the formula square root of sigma 1 to n, I is equal to 1 to n, xi minus yi whole square. The quality of the clustering is measured by using SSC technique. SSC is nothing but sum of the squared error. The formula used here is SSC is equal to sigma I is equal to 1 to k. So k is nothing but number of clusters, and sigma distance between the each point with respect to the cluster whole square. So this will give you the sum of the squared error for all the points with respect to their clusters. And we will calculate the SSC for old cluster and the SSC value for new cluster. And if the SSC value of the old cluster is less than the SSC value of the new cluster, then we will stop recomputing the cluster centroids. Let us take up an example of data points 1, 2, 3, 6, 9, 10, 12, 25. Here the point 25 is considered as outlier point because the difference of this 25 with 2 other points in the data set is more. K is equal to 2 are the initial clusters we are choosing, and randomly we are assigning 1, 2, 3, 6 to one cluster group and 9, 10, 12, 25 to another cluster group. The mean of the first cluster is 1, 2, 3, 6, that is 12 divided by 4, 3. The mean of the second cluster is 9, 10, 12, 25, that is 56 divided by 4, that is equal to 14. And now we will calculate the SSC value for each cluster group. So the mean value of the first cluster is 3. 1 minus 3 whole square, 2 minus 3 whole square, 3 minus 3 whole square, 6 minus 3 whole square. That is the SSC value for the first group. Second group is 9 minus 14 whole square, 10 minus 14 whole square, 12 minus 14 whole square, 25 minus 14 whole square. That is the SSC value for the second cluster. The sum of these squared errors is equal to 179. So this is the SSC value for k is equal to 2, in which 1, 2, 3, 6 is in one group, 9, 10, 12, 25 is another group. Now let us consider another cluster group of the same data points. 1, 2, 3, 6, 9 is in one cluster, 10, 12, 25 is in the another cluster. The mean of the first cluster is 21 by 5, that is 4.2. The mean of the second cluster is 47 by 3, 15.65. the SSE value for the first cluster is 1 minus 4.2 whole square, 2 minus 4.2 whole square, 3 minus 4.2 whole square, 6 minus 4.2 whole square, 9 minus 4.2 whole square. The SSE value for the second cluster is 10 minus 15.67 whole square plus 12 minus 15.67 whole square plus 25 minus 15.75 whole square. So this is the SSE, sum of the SSE. So that is 113.84. So this value, that is this SSE value, is smaller than the previous SSE value. So in this case, the 9 is assigned into the first cluster, but whereas 9 is very closer to 10 rather than 6. But the SSE value defined that 9 is in the first cluster is more optimal choice in this example, because the outlier 25 is taking the mean towards the 25 value rather than to 9. So that is the reason why this SSE value is less for the second group of clusters compared to the first group of clusters. K-Medoid clustering technique will provide a solution where we have outlier points in the data set. So K-Medoid clustering does not consider the mean of the data points at the center, rather than it will consider one of the point as the representative data point as a center of the cluster. It then assigns the data points according to their distance to this representative data point. So medoids are actual data points or objects from the data set, and it is not an imaginary point as in the case of K-means clustering. So as we have seen in the previous case, so here the mean of the second data set is 4.2, but there is no such 4.2 in the data set. 15.67 is the another centroid in the second data set, second cluster, but there is no such point 15.67 in the second group. So 4.2, 15.67 are assumed to be the imaginary points in the first set and second set respectively. But such type of imaginary points are not considered in the Medoid clustering technique, whereas it considers one point as the representative point as the centroid in the group. And similarly, SSE value is also calculated with respect to each object in the cluster with respect to its the mean, and the SSE is computed for all the objects with respect to the representative point. K-Medoid algorithm. Initially, we choose K points in the datasets as the initial representative points. Assign each of the remaining points to the cluster which has the nearest representative point. So initially we choose K-Medoid points. K-Medoid points are nothing but K points in the given data set as the representative points. They are the actual points. And we will assign the remaining points to these identified representative points based on their distance. And randomly select a non-representative point in the each cluster and swap the representative point with this newly identified representative point and compute the new SSE value. And if SSE value of the new cluster point is lesser than the SSE value of the old cluster point, old identified representative point, then this newly identified representative point will become replacement for the old representative point. And this process is repeated until there is no change in the clusters. So here let us see with an example. Pi is a point that was assigned to OJ previously, and a new representative point was computed, and OJ is changed to OR now. The point which was assigned to OJ previously has become nearer to OR, so therefore Pi point is assigned to OR. Likewise, K-Medoid algorithm will assign the points in the cluster group to the nearest representative points. In the next video, we are going to learn about the concept of hierarchical clustering. Thank you for watching this video.